just reworked it. So howdy, y'all. My name is Nathaniel Elliott. I'm the CEO of the Greenfield Guild, a software consultancy focused on highly automated software infrastructure. I've been in the industry for decades, largely focused on operations, and I've got a yen for philosophies, metaphors, and buzzwords. Also, I've got an obnoxious love for British television, if that wasn't already terribly obvious. So, this is a philosophical no-code presentation, by which I mean I have included no pictures of code, no deep references to code bases, and no live demos. You're welcome. So what am I going to talk about? Well, first I'm here to tell you to burn down all your architecture and start from scratch. If you walk out right now remembering only that, I've gotten at least halfway there. That is actually the core of Evergreen Development, a collection of operational and development practices that can improve everybody's lives, developers, security, operations, even management. I'll talk a little bit about the operations practices that make this approach viable and the way that security threats are evolving that I think advocate for this approach. I'll finish with a suggested stack for implementing all these practices, and all of it will be wrapped up in an extended metaphor about trees. Welcome to the metaphor portion of the talk. Probably. I'm not entirely certain. So traditional forest fire management has unfortunately proven to be bad for trees. By interrupting the natural fire cycle, traditional management allows the buildup of dead wood in the undergrowth of the forest. This produces hotter, wider-ranging fires that often overwhelm the resources of firefighters. Traditional operations doesn't see the forest fire for the trees. Traditional operations, like traditional forest fire management, focuses mostly on fighting fires. We used to brag to each other about uptime of our servers because that meant the systems they supported were probably also stable. Unfortunately, constantly firefighting leaves little time for good engineering, and so the people most empowered to clean out old systems rarely do so. Growth-only focus in business development produces a lot of dead wood, aka technical debt. Technical debt is often poorly defined and even more poorly represented on balance sheets, so most businesses don't see the accumulating piles of existential risk that it actually is. Even when they do come to this realization, they often come late and are already deeply in debt and have no coordinated plan for paying it down. As a result, when a breakout wildfire does occur, even heroic efforts are unlikely to be very successful. If an advanced persistent threat gets into a traditionally operated company, it's pretty much there until it decides to leave. There are too many vulnerabilities, there's too little ops and security can do to close them quickly. Or your system could just succumb to fragility and obfuscation so that performance problems wipe out any profits without any clear cause or good warning as to why. In either case, even if the fire doesn't destroy the whole company, good people on the front lines will be lost, either quitting in frustration or fired as scapegoats, which further endangers the company's ability to respond. By contrast, a more healthy fire management system aims to allow the natural fire cycle to continue while protecting human lives and property. A natural wildfire is somewhat disruptive to the ecosystem, but less so than a big wildfire fed by dead wood. Most animals can evade this fire and return when it is burnt out. Vegetation also comes back quicker, restoring balance to the ecosystem before rains can wash away topsoil. After a natural fire, evergreens are some of the first things to come back. They grow quickly compared to leafy trees and are often optimized for the fire cycle, having seeds that wait until a fire to open to take advantage of the clearer canopy. So what is evergreen deployment exactly? The first part is a practice called push on green, pioneered at Google. Your continuous deploy system builds your applications regularly against the latest version of their dependencies. I'll get to that in a bit. And automatically merges and deploys versions that pass their tests. This ensures that uncontroversial upgrades happen without any boring toil. Boring toil, incidentally, is another source of error, and bored humans get distracted, they mess things up, and you should aim to reduce it as much as you can, which this is doing. The second part is the practice of regularly releasing and deploying all your systems, including underlying infrastructure. Practices like canary releases, testing performance by sending a subset of work to a small deployment of your new release, can help make this more automatic and less painful over time. You can also make allowances towards efficiency, like persistent data volumes behind databases, while still keeping the software itself up to date safely. By recapitulating everything regularly, we exercise and validate our ability to recover from failures everywhere. So persistent failures here should be considered a critical issue for the project, even if they don't directly affect production performance. Batching changes together obfuscates the source of errors. By patching and redeploying regularly, you segment the problem space. Each small update contains fewer changes than the large one did, making root causes easier to identify. The same goes for the history of servers. More regular rebuilds mean systems with histories that are shorter and easier to reason about. None of this is particularly novel thinking, save maybe the extreme program-like insistence on doing it everywhere. It's applying well-understood best practices and treating stability and security as first-order targets instead of afterthoughts to the march of features. So that's what and who and what. I need to fix my slide notes. Let's do a bit of why and how. First part of why is the evolution in operations I mentioned earlier. This is the first picture I found on Pixabay for evolution and why search further. So once upon a time, operations was more or less manual, often assisted by lengthy runbook documentation and ad hoc ops scripts. Configuration management tools like Puppet and Chef grew out of attempts to standardize those practices that we already knew and that operations did manually. Container orchestration tools like Mesos and Kubernetes instead play to the strengths of automation, often in exchange for upending more traditional build and install methods. Along with this came a shift in organizational attitude. The manual world often came with the bastard operator from hell mentality, where operations and development had an antagonistic relationship over how software was deployed. The DevOps movement grew out of the realization that this was dumb and that operations and developers should work together to automate operations. Site reliability engineering is a closely related set of principles, again pioneered by Google, and adopted and expanded on by many DevOps-aligned companies. Given all of that, we're going to start with a couple of operational best practices that help improve your everyday footing. First is, have you tried turning it off and back on again? You may laugh, but this is a rote response for a very good set of reasons. What's even better, if you strictly separate build, deploy, and release, you can turn it on before you turn it off again. So, all operations aim for a repeatable architecture, but the evolved approaches get much better results along those lines. We do so because it turns out that recapitulation, which is a fancy word for build it again from scratch, it fixes many ills. There are two big ones. The first is that historical drift. If a server's long-lived, there have been a lot of fingers on it, and a lot of poorly documented changes have happened, making it hard to understand. The second is vestigial infrastructure. Software that's deployed with no real current purpose, but it's kept around because of its connection or co-location with other systems. Immutable infrastructure is an approach which builds on repeatable infrastructure. It's an approach which is only really available in container orchestration, and then only if you do it right. It relies on a principled separation of build, deploy, release. A build collects all your static requirements, your libraries, your binaries, into a static container image, usually Docker, but there are options. A deploy launches and configures that container in an environment, and then a release activates a deployed container, exposing it to that environment's workload. By separating the build from the deploy, you keep flaky build requirements from breaking deploys and releases. By separating deploy from release, you can turn it on and test it before you turn it off. Crash-only software is a similarly motivated approach from the developer side. It involves writing software that assumes that any exit is going to be a crash, and that therefore every startup should be a quiet recovery. By starting from assuming the worst, the software is insulated from a lot of common failure modes, which also feeds well into the next topic, chaos engineering. It's a related pair of radical ideas pioneered by Netflix in their Simian Army tools. The first idea is that it's easier to diagnose problems when you've caused them intentionally. And the second is that it's easier to diagnose problems at 10 a.m. on a Tuesday than 3 a.m. on a Saturday when they happen naturally. Even so, it's the practice of inviting pain, and that might initially seem foolish, but segues nicely into, if it hurts, do it more often. We all have this natural tendency to shy away from things that are painful, like the gym. Turns out that operations is like the gym, and that you only really get better at the things you do regularly. So if you don't exercise the painful process, it never really improves. So what hurts right now? Upgrading dependencies hurts. Libraries and binaries. After all, it might break something. As a result, upgrades are often delayed to avoid mutation in infrastructure that isn't immutable. When we actually do upgrade, the changes are often batched together, obfuscating the source of resulting problems. Major upgrades are also harder if you are jumping more than one major version. Ask me how I know. And even if you're only going one major version, they're easier if you are on the latest minor. And all of those things are unlikely if you are in a delay cycle. On the operations side, rebuilding infrastructure is a painful process. It's full of hard to reconstruct build chains because the last time we did it wasn't well documented, and we've changed how we do things since then. And there are strange blockers because systems are co-located. We can't upgrade PHP because we have to upgrade Apache, but we can't do that because we'll break Tomcat. Or they contain circular dependencies that require rebuilding both sides of an interface at once. Even if we deploy new versions successfully, fragile downstream services could be affected by performance changes, and you could be blamed. Because of all of this, security patching hurts. You can rebuild infrastructure and upgrade dependencies regularly, which almost nobody does well today. Or you can play the patch and pray game, where you weigh each update's difficulty against the associated vulnerability and hope that you've picked the right balance of stability and security. Or you could just abdicate entirely and hope nobody notices you're a good target until you change jobs, which seems to be sadly the common default. So, the other part of why is the evolution in threat model. This was first stock image in hacking that didn't have code with an action blur, and I did promise no code. Security is an ever-changing problem. The attack surface has been expanding dramatically, thanks in part to smartphones and the Internet of Things. There are more targets, more interfaces on those targets, and more real value invested behind those interfaces. This was probably the last nail in the coffin of the perimeter security model, which relied on the firewall to keep bad actors out. IT can't effectively manage the large variety of devices their employees use, which means that any consumer device could be a vector for an attack inside your network. Meanwhile, bad actors are getting more sophisticated. Advanced persistent threats are now big criminal business and sometimes big government business. Since the perimeter security model is well known, its compromises are equally well known, making it doubly ineffectual. The value of mutability has also been well proven, since it's often more expensive to close a security hole than exploit one. Being able to switch to new vulnerabilities keeps attackers far ahead. All of which is unfortunate because our exposed vulnerabilities are not getting any younger. According to Black Duck's 2018 open source vulnerability report, the average reported age of vulnerabilities in deployed open source software is 6 years old. And as many as 85% of targeted attacks could have been prevented by regular patching. And that's unfortunate because until security patching doesn't hurt, attackers won't even need a 0 day to get into your infrastructure. Currently, known vulnerabilities let them in easily, and long-lived infrastructure gives them places to hide indefinitely. That means most software infrastructure is pretty open to disaster today, and inability to patch quickly is prime suspect number one. All of that means that rapid defense in depth is now a necessity. If you want to have any hope of keeping your infrastructure secure, you need to be able to rapidly fix problems, and you need to be able to do it throughout your entire software stack. Continuous deployment really isn't optional anymore. So, these are the tools that I'm recommending, the how, but they're not the only way. And we won't even use them 100% of the time. So I'm going to talk in generalities rather than deep specifics. Making recapitulation more automatic is a two-pronged approach. Converting the vast majority of your infrastructure into Kubernetes containers gives you application level recapitulation, largely for free. Automating the remaining infrastructure, hopefully just Kubernetes itself, but realistically you're going to have some one-offs outside of it, can usually be addressed with Terraform. Unfortunately, Terraform is less flexible and a little more confusing than Kubernetes. But it's still kind of the best open infrastructure tool I know for cloud deployments. Bare metal is extra tough. Contrary to the name, it's anything but bare. Each environment has usually got unique constraints and unique this and that and the other. No, it's bare like the animal. Right, I should well played. Tools like Rebar or Cobbler can provide netboot support, which can help a lot. But they're complicated. Where possible, I recommend leveraging existing systems to get Kubernetes and then work backward to better infrastructure automation once container orchestration has proven its value. Once you've got automatic recapitulation, regular push-on-grid rebuilds of your code base are pretty simple via your CI system. I like GitLab, but you got plenty of options yet again. Unless you've got a greenfield project, individual applications are probably the low-hanging fruit here. But don't neglect rebuilds of the infrastructure just because it's harder. Infrastructure systems are a juicier target, especially after your apps are well secured. Next, instrument and automate upgrades of your code. This is a very language-dependent step, though tools like RenovateBot make a credible attempt at cross-language implementations. And then finally, automate the opening of problem tickets for upgrade and rebuild failures and treat them as business critical. Developer culture has this big thing about you break the build, you fix it, and that won't work here because it's an automated process that's breaking it a lot of the time. The answer is to treat it as part of your incident response system. Whoever's on call needs to at least look at it, and maybe you created a larger ticket or something. The wrong answer is to pin to the version that did work, never upgrade, and backlog the fix. That wrong answer may be a necessary evil in some short-term scenarios, but please don't let the dead wood pile up. Okay, that was a lot to cover in 20-some minutes. The rest of the time is open for questions, and I'll be available for some additional conversation afterwards.
So this isn't a question for you, but to the PHP folks here, since this is related to the topic you covered, everyone that does PHP stuff in production, how often do you update your composer.log file?
That uncomfortable silence says some things.
So, what are your answers?
Anytime we install a third-party library, composer log file is put into the repository.
No, but I'm talking about the Who else does PHP introduction?
Not often enough. I was gonna say probably like once every 2 weeks, every week or so.
So that,
We update in the repository, then deploy everything to a staging environment, test everything there, and then
That's good. You're already a good portion of the way there.
agreed. So, next, who else? Who else does PHP?
Sorry, since you asked that question, we've switched all of our systems over to COBOL to avoid answering that question.
So on the topic of GitLab though, I have a cute little script I implemented that what it does is every week, like Monday, it automatically does a composer update and like a new branch it creates, and then creates a merge request saying like automatic composer update, and then you can
Yep.
see like which packages update.
That you are,
Merge.
yeah, you are pretty much doing what I'm prescribing there.
Yeah.
About the only other thing I would say is take yourself out of the loop. Get some good testing around that and make that upgrade fully push on green.
That's some good testing. It's just
So Paul, in your PHP shop, how are you doing with automated testing?
What'd you say?
So Paul, you work at a PHP shop. How are you doing with automated testing?
We're writing tests every day. Let's put it that way.
That sounds like 7 times as often as you update your dependencies, so it sounds like you're doing pretty good.
Anyway,
got a question about that for you. So when you commit those updates automatically, are you committing like one big blob of updates, or are you committing each one individually?
it's the merge request is all the updates, but because they like happen every week, it's like not too many usually.
Yeah, it's back to that batching thing I was saying.
And it's it doesn't like automatically commit to master and deploy. It like makes like a merge request for it, so you can like look at which ones it is and like see if the build failed or not and stuff like that.
I got that part, but I'm saying each package that gets updated, is that in its own commit, or
No,
is that?
it's it's all in one commit.
Yeah, my preference is to have them all, every update in its own commit, so that if I have to roll something back, I don't have to roll the whole and just block back. But sometimes that takes a little longer, because instead of having one commit, you have 10 commits if there's 10 packages updated.
And one thing to note here is DependabOt, which is now owned by and somewhat integrated into GitHub, actually has it will make pull requests automatically on a per package basis. And if you
Oh,
want to
nice.
if you want to merge them as soon as you see them come across, you can probably add an automation for that. But
Yeah,
I am pretty sure it works for private.
so you have to run it for yourself. Well, okay. I haven't dug as deep into the SaaS side, so I can't say for certain. I believe GitLab and GitHub, it supposedly works for all repos at the moment, but that's their marketing talking, not me testing it out. They also AGPL license the core, so you can run it yourself.
What you were saying about doing individual merge requests, we do them all, every update's a single commit, but we do it all as one pull request.
That sounds like a preferential thing. I would kind of prefer the block, but everybody's got different preferences on how to do Git, and I try not to get in a fight about it.
Nathan, can you put your slides up in the comments?
Absolutely. I will do so when I get home.
So I learned, I guess it was today or last night,
Actually, I might be able to do that. Sorry? Oh yeah, it just got sold. Who bought it?
Marantis.
Marantis. Interesting.